Alright, we're going to go through these a little bit more quickly now, so if you need a refresher as far as where the numbers come from, feel free to go back to that first video. But we've got Cn with a negative charge, so the number of electrons that it actually has, well, we've got 1 carbon times 8 electrons for carbon, and 1 nitrogen times 8 electrons for nitrogen. That's going to give us 16 electrons that would make everybody happy. We actually have, well, still 1 carbon, but carbon is in group 14, so it has 4 valence electrons. Still have 1 nitrogen that's in group 15, so it has 5 valence electrons. And that negative means that we have 1 extra electron. So that's going to give us 10. If I do the math here, 16 minus 10, that'll give us 6. Divide that by 2, 3 bonds. So we're going to have carbon and a nitrogen, just 1 carbon, 1 nitrogen. We need 3 bonds, so simple as a triple bond. Going through to make everything happy, we need, this carbon thinks it has 2, 4, 6 electrons, so we need 2 more to give it 8. This nitrogen thinks it has 2, 4, 6 electrons, we need 2 more to make it happy, to give it 8. And since it's an ion, we've got to make sure that we put the whole thing in brackets with the charge of the ion outside of it. This next column, the ABE notation, it's a little tough for elements that just have 2 atoms. Whether they be the same atoms or different atoms in this case. Just arbitrarily choose one of these to be our central atom, so we'll call the carbon our central atom, so we'll just write A. And how many atoms is this carbon bound to? Well, just 1, so we would just call this AB. And how many pairs of electrons are hanging off of this central atom? ABE, just 1 pair of electrons. Well, we don't have a notation for ABE in our paper, but to figure out our shape of this, it's real simple. What's the only shape that we can make with 2 points? So if I have a point here and a point here, one representing carbon, one representing nitrogen, the only shape that I can make by connecting those is a straight line. So this is linear, EAR, for the geometry for that one. And then our last column to figure out if it's polar or not, well, we're going to take a look at the electronegativities for carbon. Carbon, if you look at the periodic table, has an electronegativity of 2.5, and for nitrogen it's got an electronegativity of 3.0. So 3.0 minus 2.5, that'll give us 0.5. Obviously, if you do it in this order, you're going to get a negative 0.5, but our differences, just make sure that they make them positive. So absolute value are always smaller number subtracted from the bigger number. So if we look to our sheet in terms of what type of bond with the electronegativity differences of 0.5, we find that this is a polar bond, but that doesn't necessarily mean that we have a polar compound. So let's go. Is there a polar bond? Yes. And then the next question we ask ourselves on the flowchart is, are there lone pair electrons in our central atom? Now remember, we called this our central atom, but the same thing would be said with this guy here. So yes, there are lone pair electrons in our central atom, so this would be polar if we answered yes to that. Cool, that's number 2.